This is a short demo of the wan-ai internet technology, and what we have here is a live stream of measurements from a router in a real-world broadband network. What these measurements tell us is the level of activity at the network router, which can include, for example, the number of internet connections that have been established and the data demand that is generated by each internet connection. Clearly, this is a large volume of data to process if what we're trying to do is to keep up with the huge demand for data on the internet. But quite apart from this big data problem, another challenge we face is related to the design principle of the internet. This is a diagrammatic representation of the network router, and what we see depicted here are shared resources such as a buffer of memory and a processor that is forwarding packets. Depending on a whole host of factors such as the ratio of the long to short data flows and the geographical distance between senders and receivers, we can get a very uneven distribution of the resources available amongst the competing data flows or internet connections. What this means in practice is that given a particular resource allocation, it is very difficult to predict precisely the quality of experience for any particular subscriber. The scale of the problem is made clear when we consider that at any given moment, there's hundreds of thousands, if not millions, of internet connections that have been established at hundreds, if not thousands, of network routers, and the task of making sense of what is happening on the internet becomes truly monumental. Such a task requires computation on a massive scale and has previously not been possible. The wan-ai solution makes it possible to directly relate the resources available with the quality of experience. wan-ai is a unique combination of an ultra-fast computational engine that predicts the subscriber experience with artificial intelligence that reasons about the best allocation of resources on the internet. With wan-ai, it is possible to answer difficult questions such as what is the minimum bandwidth that supports HD streaming across the entire network in real time. Apart from the huge network operation advantages, wan-ai is aligned with a few major trends in the industry, such as affordable connectivity. This means cheaper and faster internet for everyone. Network automation and orchestration. This means allowing the network to respond to data demand on internet timescales and transaction volumes. Sustainability. This means reducing the energy requirements for always-on connectivity. If we look at a particular iteration of the wan-ai computation, what we observe is that the artificial intelligence reasons about a given optimal resource allocation, such as the bandwidth, and the computational engine then predicts the subscriber quality of experience. For example, the artificial intelligence predicts that this is the optimal bandwidth investment option for the upstream and downstream, and the computational engine then predicts the subscriber performance in megabits per second on a packet level. This is the first time such a computation has been achieved in real time. Thank you.